In lesson 94, we're going to look at what's called the law of sines. Now, the law of sines, previously we've done things like, sine, cosine, SOHCAHTOA, using sine, cosine, or tangent. But previously they were for a right triangle. Well, we're going to look at a way to use sine without having a right triangle in the problem. The law of sines, what it means is it's basically a series of three ratios. So in a triangle here, imagine all of our angles, we use the big capital letters of A, B, C. And for all the side lengths, we use a little a, B, C. Notice they're across from all of the corresponding letters. And all your ratio is little a, okay, the side A over sine of A. So say angle A here was 32, then it would be sine of 32, okay? Sine of 32. Okay, I'm just throwing something in there. But that's what you would actually plug in the number for the letter. And then you would have B over sine of B, and then C over sine of C. So now let's look at an example of how we may use this. Example 1. So it looks complicated, law of sines, that can sound intimidating, but it's really nothing too difficult here. So in example 1 it says find xz. So we need to find this one. Now I'm just going to show you this one by setting up all the proportions. So in this one we did side length over corresponding opposite angle. So let's go ahead and do xz. Okay, xz over sine of 38. xz is across from sine of 38. Then we can do 20, we know that side length, over sine of z. Now we can know what z is because triangle sum theorem. 35 plus 38 plus z will all equal 180. So when we solve for that, 35 plus 38, okay, 180 minus 73, we come to find that this is 107. So I can say sine of 107 degrees. And then moving on, we could say yz over sine of 35. You don't have to do all three of those. I'm just showing you what your ratio or proportion would look like in this triangle. Now from here it said to find xz. So here's xz. Now we need to combine it with a proportion where it's only going to have one variable. So for example, my two different proportions I can do here, if I'm finding xz, is I can do xz over sine of 38 equals 20 over sine of 107. That's one proportion I can do, or I could do xz over sine 38 equals yz over sine 35. The problem here is I have two variables. I have a variable in xz, side xz, and I have a variable in side yz. So that leaves it unsolvable. So we erase that one, or know that we can't use that one. However, here we know what this side length is, so we can cross multiply and solve. So I cross multiply 20 times sine of 38 equals xz times sine 107. Alright, now I'm going to use the calculator here. 20 sine 38, type that in wrong, 20 sine 38 is 12.31. 12.31. Now I can know what sine of 107 is. I can plug in sine 107 in my calculator, and get roughly 96. And that's times xz. So now to find xz, we simply get it by itself by dividing. So 12.31 divided by 0.96 comes out to be roughly 12.82. Okay, so 12.82. That would be my answer. I don't know if it said around the nearest hundredth or whatever. Yeah, nearest hundredth. So that is roughly your answer. That 12.88, 12.82 would work. So all it's going to do is have you solve for different things. Now maybe, I know in example 3 I'm not going to go through the whole thing, but it might give you both sides. Okay, say this side we already knew was 12.82, and we need to define the sine of, what's the opposite of 12.82? Sine of y. Okay, well we can once again just set up this proportion, and I'll just kind of show you here. We can set up this proportion. If we're finding y, sine of y, that'd be, okay, we could cross multiply 12.82 times sine of 107 equals 20 sine of y. Once again, this isn't in this problem, this is example 3, but I'm just kind of fast forwarding a little bit just to show you, because some of the problems will do this. So if I typed in 12.82 sine in my calculator, or 12.82 sine of 107, that'd be 12.26 equals 20 sine of y. Now I got to get y by itself. So I'm going to divide by 20. So this divided by 20, 0.61 equals sine of y. Now to get y by itself, I got to divide by sine, and that's when we do the inverse of sine. So inverse of sine 0.61 comes out to be 37, and it says 37.6 roughly. Notice that is basically the same as that, right? So you would just do the inverse and whatnot. But that is how you do the law of sines.